Welcome back, guys. Today we're going to continue on with a lesson on laws of logarithms. In the previous lesson, we looked at three individual laws. We looked at the product law, the quotient law, and the power law. And now we're going to take and look at some examples that put these all together. All right, so before we get into our examples, let's just do a quick refresher on those laws. So for the product law, if I have the log base a of m plus the log base a of n, that's the same as the log base a of m times n. So if I'm adding two logarithms with the same base, I can combine the arguments by multiplying. For the quotient law, if I have log base a of m minus log base a of n, I can combine them by dividing my arguments. So log base a of m divided by n. And the last one is the power law. We use this one quite a bit. If I have log base a of m to the n can actually come forward, and we have n times log base a of m. All right, so taking a look at our first example here, we have three students who were asked to simplify the expression 4 log base x of 2 minus log base x of 8, and they were asked to combine this into a single logarithm. Now the three students did their work below here, but only one student has done the question correctly. So we're going to take a look at each example and see where some mistakes may have been made. All right, so taking a look at Lauren's work here, we have 4 log base x of 2 minus log base x of 8. And looking at her next step here, she's kept the 4 log base x of 2 the same, and she's changed the log base x of 8 by rewriting 8 as 2 cubed. Well, 2 cubed is 8, so this step is correct. In her next step, she kept the 4 log base x2 the same, minus, she's brought the 3 ahead to become 3 log base x of 2. That's using the power law, so this is correct. And then she said 4 log base x of 2 minus 3 log base x of 2 is log base x of 2. So essentially she's saying 4x minus 3x is 1x, and that x being the log. So this is correct. So Lauren has done this work correctly, which means Jamie and Katie must have made some mistakes. So let's take a look at their work. Starting off with Jamie's, we have our first step here saying log base x of 2 to the 4th. So she's brought the 4 up. That's using the power law. That's fine. Now the next one here, she's got log base x of 8. Nothing's changed, so we're good there. Now our next statement here, we've got log base x of 16. Well, 2 to the 4th is 16, so that's correct. And the rest has stayed the same, so we're good. So both of these steps are correct. Our last step here, then she's got log base x of 8. Well, we know that she's made a mistake, so let's see what she's done. So she's taken log base x of 16 minus log base x of 8. Well, if we're using our quotient law, what we should be writing is log base x of 16 divided by 8, which would become log base x of 2. So her mistake is that she used her quotient rule incorrectly, or her quotient law incorrectly. All right, now our last example here is Katie. Now Katie has started off with her first step going log base x of 8. So what she did is instead of bringing the 4 up to become 2 to the 4th, she's actually multiplied the 4 by 2. So her mistake happens right here. Now going forward, she went log 8 minus log 8. Everything else would have been correct based on her mistake. This is where if you had done this question in class, I would typically be writing ECT. So she's made a mistake, but she's carried the rest through correctly. Now, because had she not made that mistake, her steps would look the same as Jamie. So I won't continue on with that one. All right, let's take a look at another example here. So we're being asked to use the laws of logarithms to write each of the following as a single logarithm. Now, as we work through these, we're going to be using all three laws, the power law, the quotient law, and the product law. Now, if I see a subtraction sign, that should be a cue to me to do the quotient law. Anytime I see numbers or coefficients in front of the logarithm, that tells me to use the product law. So I will often start with my product law by bringing these forward. I can't do anything else until I have my arguments simplified. So bringing that 1/2 up and bringing the 1/3 up, we can do these in the same step. We have log base a of 16 to the 1/2 minus log base a of 8 to the 1/3. Now this is where it's really important that your logs stay in log land and your exponents stay in exponent land. Writing this out, I don't want to see anything like this, log a 16 1/2, because then we can't tell what goes where. So log base a, so the base needs to be clearly in log land. The 16 is level with the log, and then the 1/2 is up in exponent land. So there should be some clear definition in terms of what's being written. All right, so let's continue on here. So we have log base a of 16 to the 1/2. 16 to the 1/2 is the same as square root of 16, so that becomes log base a of 4, minus log base a 8 to the 1/3 is the same as 2, so the cube root of 8 is 2. Now we have single logarithms, or individual logarithms here written. We've got a subtraction in between, so we can use our quotient rule. So log base a of 4 over 2 will give me log base a of 2. So if you wanted to label what we were doing here, we used our product law, then we simplified, and then we used the quotient law. All right, let's take a look at our next question. So we have log a minus 5 log e minus log a squared. Again, we see subtraction signs, so there's probably going to be a quotient law involved. And so our first step here is to actually move our 5 up. So we're going to have log a minus log of e to the 5 minus log a squared. So again, anytime that we have numbers in front or coefficients in front, we're typically going to be moving those up. Now I'm going to combine these first two terms and then we'll deal with the last term. So combining these here, we're going to have log a divided by e to the 5th minus log of a squared. Again, we're still subtracting, so we can divide by the a squared. That will give us log of a over e to the 5th. When we divide by a squared, that goes to the bottom. And then we can simplify. So a on the top divides out, we're left with 1, a squared on the bottom. And so rewriting this, I've got log of 1 over a e to the 5th. And there would be our final answer. Writing out the steps, the first thing we did was use the product or the power law. Then we used the quotient law. And then we use the quotient law again. And then we simplified. So sometimes these questions are almost like a puzzle. We just have to look at what we're given, look at the 3 rules, and see which ones fit best together. All right, moving on to example number 3, we're asked to write the expression 2 log base 6 of 4 plus log base 6 of 2.25 as a single logarithm and then evaluate. So these are very common questions. We're asked to simplify first and then evaluate. All right, so by simplifying, I'm going to start off by writing the question out. So I've got log base 6 of 4 plus log base 6 of 2.25. I see an addition sign, so that tells me I'm probably going to be using the product law. I also see a number in front, and so I'm going to start by dealing with that first. I'm going to bring that 2 up, and so that's going to give me log base 6 of 4 squared plus log base 6 of 2.25. My next step is to simplify, and then I can combine using the product law. So log base 6 of 16 plus log base 6 of 2.25. Now that everything has the same base and everything's been simplified, I can multiply my arguments. So 16 times 2.25 gives me log base 6 of 36. Now at this point, you can just put it into your calculator, or if you want to simplify, we can write it as log base 6 of 6 squared. Notice that if I have log base 6 of 6 squared, I can rewrite that as 2 log base 6 of 6, and this simplifies to become 1, so I'm left with 2. Now, that's how I could do it without having to actually use my calculator, but you could certainly type in log 36 over log 6 in your calculator and also get 2. All right, taking a look at example 4, these are very common examples that we'll get. We'll be given a value for our logarithm, and then we'll be given an expression that we have to simplify or rearrange in order to get to that value so that it's usable. So the first we're told that log base 5 of p is equal to 12. So anytime that I have the expression log base 5 of p, I can rewrite it by substituting in a 12. We're being asked to determine the exact values of these expressions. So the first one, we have 5 times log base 5 of p. Well, this log base 5 of p can be replaced with 12. So we're going to have 5 times 12, which is 60. Looking at our next question, we've got log base 5 of 5p. Well, this is our argument 5p. That doesn't help us until we separate things out. So these are being multiplied. That tells me that I can go in the opposite direction and add my logarithms by separating my argument. Now I have log base 5 of 5, which we know from our properties yesterday or in our last lesson is 1. So log base 5 of 5 is 1. And we know that log base 5 of p is 12 because that's given to us in our original statement. So 1 plus 12 is 13. And our last question, we've got log base 5 of 25p cubed. Now there is a tendency for people to want to just bring the 3 forward, but the 3 doesn't apply, or that wouldn't work unless I had an expression that looked like this. Log base 5 of 25p, and then this whole thing is cubed. But the p cubed is, or the cubed is only applying to the p, so I need to separate things out first. So I'm going to start off by rewriting my expression. And I'm going to have log base 5 of 25 plus log base 5 of p cubed. Now I can simplify. Again, log base 5 of 25 you can just put straight in your calculator. I like to do it where I don't need my calculator. So log base 5 of 5 squared plus 3 log base 5 of p. Bringing my 2 forward, I'm going to have 2 log base 5 of 5, which we know is 1. So this is going to cancel out and be 1. So writing that there, I've got log base 5 of 5. We know that's going to cancel out to become 1. And we have 3 times that log base 5 of p, which we know is 12. So we now have 2 plus 36, which is 38. Now again, that log base 5 of 25, you could go straight into putting that into your calculator. You don't need to do these other steps, but I'm showing you how you can do it without actually having to touch your calculator. All right, and our final question, it says if log base 2 of x equals a, we're going to be asked to use the laws of logarithms to show that log base 2 of 32x squared is equivalent to 5 plus 2a. I'm going to do this using a left side, right side chart and simplifying as I go. Try doing that again with some straighter lines. All right, so make our left side, right side chart here. And so we've got LS, RS. All right, so starting off, we've got log base 2 of 32x squared. And we're trying to show that that is equivalent to 5 plus 2a. So the first thing we're going to do is separate our logarithm into 2 separate logs. So log base 2 of 32 plus log base 2 of x squared. Then I can bring my 2 forward using the power law. And so that will give me log base 2 of 32, which we can evaluate already at this point, plus 2 log base 2 of x. Now, again, log base 2 of 32 can be done in your calculator. If I want to write it out as base 2, I can do that. Log base 2 of 2 to the 5 plus 2. Now, we already know that log base 2 of x, based on the statement above, log base 2 of x is a. So we're going to take and replace this with an a. So that gives me log base 2 of 2 to the 5th plus 2a. Well, this 5 is going to come forward, so we're going to have 5 times log base 2 of 2 plus 2a. Log base 2 of 2 is 1, and so that's going to leave me with 5 plus 2a. So looking at our expression on the right-hand side, we know that both sides are equal, so we can check it off and show that left side equals right side. All right, so that's only a few examples, but hopefully it gives you enough to understand how we can combine our expressions or rearrange our expressions using a combination of log laws. Do a few practice questions, and we'll see you soon.